All right, then I'm going to introduce you and then hand over to you.
Okay.
All right. Hello, everyone. Good evening and welcome to our monthly meetup. Nice to see all of you here, and I hope you are all keeping safe. Hopefully, we might start, meeting in person in a very short while. Today's presentation is going to be very interesting. We have a guest speaker and also the sponsor for the meetup, and his name is Shimon, and he is from a company called The Tree, and he is going to introduce himself, tell us briefly about what they're doing, and then after that, I will take over the microphone and then talk about the main presentation for today. So let's pass the microphone to Shimon to introduce himself. Shimon.
Thank you very much, Damien. It's an honor to be here. Thank you for hosting us.
You're
So
welcome.
I'm going to share my presentation. Hopefully you're able to see it. Great. So my name is Shimon Toltz. I'm the CEO and co-founder of The Tree. But I feel at home because I'm also a CNCF community organizer out of Tel Aviv. And together with that, I've been very active within the infrastructure DevOps communities. I also lead one of the largest AWS user groups worldwide. I'm an AWS community hero. And this is what I do. I really love infrastructure, backend, DevOps, and so on. And in my previous role, I was leading the infrastructure division for 400 developers. And this is where I felt a lot of the challenges that we're dealing with. So I'd love to take up like 2-3 minutes of your time and tell you a little bit more about what we do and how we can help you. So what we do is we help prevent misconfigurations from reaching your Kubernetes. And we do that by providing a CLI utility that is open source. You can see it in github.com/thetree or /thetree. And the way we do it is every time there is a change made to your Kubernetes manifest or to your Helm charts, our CLI utility runs and checks against predefined sets of policies that you can control in a centralized way. For example, you can make sure that you have a memory limit set for all of your workloads. So a little bit about the tree. So we are more than 3 years old. We are well funded. We're a Y Combinator company and we raised more than $10 million and we have great companies using our products. But I want to start with a personal story of what brought me to actually start the company together with my co-founder. So in my previous job, as I said, I was an engineering manager for an infrastructure division. And we had more than 400 engineers. And one day, one of the engineers made a mistake, which is okay. I always make mistakes as well. Everyone makes mistakes. But the problem was that once we've identified the mistake that the person did, we had no way of propagating what they should do and how they should avoid making this mistake ever again. I tried sending emails and writing docs and doing meetups and educating the developers in my company to not make the same mistake again. But it was mission impossible. Even if you have tens of engineers, it's really, really hard to coordinate their work. And this is why we said this has to be done in an automated way. And this is why we've started the tree. So as you can see, we're a company by developers for developers, and it is really easy to get started. It's just one command to install the tree, and I will show it to you in my terminal in a moment. And once you install it, you can run automated tests against your Kubernetes manifests. So I'm going to switch to my terminal, and I'm going to invoke the installation of the tree, which is, as I said, open source. And as you can see, it is very, very simple. and now the tree is installed on my machine. Next, what I can do is I can run the set of tests against a demo file that has some misconfigurations in it. So maybe first I will show you the file. So it is just a regular Kubernetes manifest that has some challenges to it and could be configured better. So let's run the tree test command against this Kubernetes file. So it is running, and now as it finished, we can see the results of the test. So first, the tree determines whether it is a valid YAML file, and it is. Secondly, it validates the schema of my configuration against the Kubernetes version that I've configured. In this case, it is valid. And then it runs the policy checks. So in this case, we do not have labels set up. We are using a Docker image that does not have a specific version to it. It just uses the latest version. So if we will have issues in production, it's like going to the casino. You don't know which version is running live now. We don't have a liveness probe, and we don't have a memory limit. So here I can see the summary of the checks. And of course, you can do the same using Helm charts. And then you can go to our centralized dashboard. And this dashboard allows you to configure your policy in a centralized way and to view the invocations for all of your organization in one place. So as you can see, this is the last invocation that we made. And in this tab, you can see the policies that are configured in my account. And I can enable and disable any policy that I would want. And I can also change the output text that will be printed for the developers. And this way, in a centralized place, I can configure the policy, and then every time a developer makes a code change, they can run it in their computer, or what most of our customers do, they just incorporate the tree within their CI/CD, and then every time there is a code change to your manifests, the tests run automatically. And if they fail, the developer will be notified on how to fix them, and this way you can prevent possible production outages from happening. So this is what we do. Go out, check it out, and feel free to send us feedback and tell us more. Check out our predefined policies. We have more than 30 policies ready for you to just use, and we're very, very eager to hear your feedback and incorporate your requests. Thank you very much for having me.
All right, thanks, Shimon. So thanks for that introduction. I've seen some of the demos you do, and being in the community, I really appreciate the work that you guys are doing, and I hope that some of the audience here will start to play with the features. So you said it's all open source, right?
Yeah, you can see it in GitHub. It's written in Go. It's really nice. People actually made pull requests. Someone created the pre-commit hook. You can also do whatever you want. We're really welcome to it.
All right. Is there like a Go, get started page that people can explore?
Yeah, so I'll link it in the chat. I will link our project in GitHub, and you can just open issues and talk to us and reach out. We're really friendly. You can also reach out on Intercom. Feel free to engage us.
All right. Sounds good. Thanks for coming. And very soon, we hope to see you to make some other presentations when you have the time.
Thank you very much.
All right. So now I'm going to switch over to my own presentation, and then we'll take it from there. So Shimon may not stay with us throughout the entire time, but it's okay. So now we're going to explore Kubernetes. And I know that most of the things Shimon talked about, you may not be familiar with them if you haven't been working with Kubernetes, which means you may not even be familiar with policies. So what I normally do in my presentations is to bring everyone kind of up to speed with where you can start to understand the things that I'll be talking about. So my presentation is normally going to be in 3 parts. First is to introduce you to Kubernetes so that you don't get lost. Second is I'm going to review what we've been talking about in the past couple of meetups, and then I will start to talk about what I need to talk about for today. So once again, welcome to this presentation. So my name is Damien Igbe, and I hope you can see my slides. So I'm the main sponsor for this meetup. We've been doing it for some time now, and no doubt we're one of the largest meetup in North Dallas or in the Dallas metropolis at the moment. And thanks to you guys for those of you that keep showing up. So also the company I work for called the Cloud Technology Experts, we are the main sponsor for the meetup. So that is a website. We are producing content along Kubernetes and microservices. Some content have been developed, and I hope that, for those of you who may be wanting to learn about these technologies, you have the resource for you to learn. Check out the website, and when things get ready, you can, continue to learn on the website. Okay, so normally we're kind of 2 or 3 presenting, or at least helping out, but I'm the only person today. So if you have your questions, please send them to the chat, and I'll keep an eye on it, and then I'll come back to those later on. If you have something to discuss, feel free to, put them through the chat. Okay, so that is how we're going to proceed. So I'm going to start by introducing Kubernetes. And then before I talk about the main topic for today. So the main topic for today is exploring RBAC in Kubernetes. RBAC means role-based access control. So that is what we're going to explore. And the agenda, we're going to, and again, take you through the overview of Kubernetes, take you through Kubernetes security overview, and then we can start the presentation that we have for today. All right, so Kubernetes is becoming is a de facto orchestrator for microservices. So if you're not familiar with it, I'm just going to give you a brief overview and why it's becoming so important. The main thing is that people are migrating the applications from on-premises to the cloud environment. And as people do that, they need to refactor their applications, because the applications you have in-house don't work very well in the cloud. So these applications need to be refactored. They need to be redesigned and developed to work effectively in the cloud environment. And this was this observation that applications moving from on-prem to the cloud doesn't work very well was something that most of the major corporations like Netflix and Google and Facebook and the rest of them, they experience it. And so they came up with this architecture now called the microservices based architectures. And so just in a brief introduction, the applications we have on-premise are called the monolith applications. These application architectures, they normally have all the components developed as a single binary. And then this application single binary get deployed onto the deployment platform, all right? And if you need to scale, then you need to pretty much replicate the server where the application is running. When you move to the cloud, that doesn't go very well. So the new architecture is like what we see here on the screen, where you break down your application into several components. Then each one of these components get developed as a single autonomous application. And when you do that, you convert a single application into a distributed application. And when you convert a single application to a distributed application, you have a lot of challenges, okay? Because distributed applications are complex. They have a whole lot of things going on. Especially, you have to deal with communications between those components. You have to deal with making sure that you load balance the workload. You need to make sure you deal with security, logging, monitoring, a whole lot of stuff. So they were trying to solve a problem, but the solution, unfortunately, is a little bit complex, but it's fine. I don't think there's any other way they can do it. Okay, so in handling those challenges, was one of the reasons that Kubernetes became very, very popular, because Kubernetes is very good in helping you to manage this microservices-based architecture that people are predominantly deploying in the cloud. Okay, so that is kind of the background to Kubernetes. And usually when you talk about Kubernetes, you also have to talk about Docker, because Kubernetes orchestrates a containerized environment. The most common container platform is Docker. So once you understand Docker, now you can understand how to use Kubernetes to orchestrate or manage this infrastructure. So see Kubernetes to be like your cluster manager. Okay, so I'm going to show you the architecture of Kubernetes, and then we can take things from there. So this is what the architecture of Kubernetes looks like. We have two major divisions, or major two major categories of the architecture. First is called the control plane. The control plane is this box here, and then this is called the data plane. So the control plane has a lot of components. First one of them is the Kube API server. This is the main service that is responsible for handling everything going on in the Kubernetes cluster. In fact, when you start to use Kubernetes, this is the component that you're going to be interacting with. Okay, then we have these other components like the Kube Controller Manager. We have the Kube Cloud Controller Manager. We have the etcd, which is the key value store database. We have the scheduler, which is responsible for distributing your workload to the data plane. So let's say you want to run a microservice on your Kubernetes cluster. The scheduler is the one responsible for ensuring that your workloads are evenly distributed across this number of nodes. Okay. So on the data plane, we have on every node we have the Cubelet, which is the API server on each of the worker nodes. Okay, that is the one that has to coordinate with the API server on the control plane. Then we have the Kube proxy, which is responsible for managing all the low-level networking that need to happen, like setting up the firewall rules and IP tables and all that for the networking to work. And then also not shown here is the Docker. You need to install Docker on each one of these nodes that we have here. All right, so that is kind of like a very short introduction to Kubernetes architecture. In fact, if you go back to some of the previous meetups, or in fact, if you go to the Kubernetes website, you should have more detailed information about what I tried to summarize here. Since this is not the focus for today, so I'm not spending a lot of time here, but you can go back and watch some of the previous videos. Okay, so one thing I want you to understand more from here is that we call this a cluster. This is a Kubernetes cluster. So when you deploy this Kubernetes cluster, it's possible for you to have many nodes, many computers, many virtual machines, all of them working as your cluster. So the largest Kubernetes cluster available at the moment, I believe, is somewhere around 5,000 nodes. So it's possible that all these nodes we have represented here are about 5,000 nodes that you have to manage. But from the administrator perspective, you don't have to worry so much, because there's a tool called the kubectl. Kubectl, I'm going to show you here as I do the demos. Okay, so this tool here called kubectl is a tool you're going to use for managing your Kubernetes. Of course, you can also manage it from the dashboard, but if you are not doing it from the dashboard, then this is the tool you're going to use in managing it. All right. So what you see here is I already logged on to my cluster. This cluster is set up here within my network. And so I can access it from within my network, but you won't be able to have access to it because it's a private cluster. So I already logged onto it. And if I say Groupctl get nodes, we'll see how many nodes I have on this cluster. It's showing me that I have 4 nodes. Okay, one is the master. You can see here the control plane, or the master node. And then these 3 are the worker nodes. Okay, so all the components I mentioned in the architecture, if I do kubectl get pods -n kube system. I will see all the components I mentioned earlier. You have the API server there, you have the control manager there, and then you have the kube proxy there, and then you have the scheduler is there, and then a bunch of other components. Okay, so I have the cluster deployed here, pretty much comprising of 4 nodes, and this is the cluster I'm going to use for making the demos that I'm going to show you for this presentation. Okay, so that is kind of introduction to our Kubernetes architecture and the environment that I'm going to be using. There are different ways to spin up your cluster. You can go to AWS, you can go to any cloud provider, and you can use their managed services, or you can deploy it yourself. This one here, I deployed myself using a tool called KubeADM. Okay, and really, if you don't want to be a Kubernetes administrator, you may not bother so much with this. Some just want to use a cluster. Some need to learn how to use a cluster and also how to create clusters. Okay, but in any case, that is the introduction. We'll be using this tool a lot, the kubectl tool that I have here. Okay, so going back to this series that we're on, we've been talking about Kubernetes security. And this is a very important part of Kubernetes because, as you can see, security is becoming even more and more important in our today's architecture. There have been a lot of hacks, and you hear these stories every now and then. So it's very important for us to understand how to manage security in our Kubernetes environment. And it's one thing to play with Kubernetes on your laptop or in a testing environment. It's another thing to actually start to deploy Kubernetes in production. When it comes to deploying Kubernetes in production, you really have to pay attention to how you're doing things to ensure that your workload are secured. And really, this is not meant to be beginner sessions because for you to start working on security, you need to have a good knowledge of how Kubernetes works. Okay, so I can understand in some of the demos today, if you are completely new, you may not fully understand them. It's understandable. But if you go back at any point in time and you start to look at them, that will make sense to you. So when I started this series, the first meetup was I gave a kind of overview about Kubernetes security architecture. And there was a slide I use here which illustrates the different layers that we need to worry about when it comes to our cluster. So let me show you that quickly. So we call it the 4 C's, the 4 C's of Kubernetes security. And that is a diagram here, okay? So in the diagram here, we have the outermost lane, the outermost C, which is the cloud environment. Like I said, most people will deploy their cluster in a cloud environment, be it AWS or Google Cloud or Azure, whatever it is. So you need to ensure that your cloud is secured, because if you don't, that could be the place that people would come in. All right. Then after that, you have your cluster, the Kubernetes cluster, the architecture I showed you earlier. This is where you run your Kubernetes cluster. And then after that, you have to also take care of the containers. You know, where your microservices are running. They are running in containers inside your Kubernetes cluster. So you have to take care of the security also inside those containers. And finally, the last C is your code. When you write your code, be it Python or JavaScript or whatever language you're using, you just need to ensure that you follow the security best practices in writing your code so that you minimize areas that you could easily get hacked. Like you try to write good codes following best security practices for your platform. Okay, so first day I gave a kind of overview of each one of these. I went a little bit more detailed into each one of them for us to understand. Then now we're pretty much on the cluster layer where we see how to secure our Kubernetes cluster. So last time, the last month, we talked about authentication. That is, how do you get people into your Kubernetes environment? And how do you make sure that these people you are getting in, you are managing them in such a way that is it doesn't involve a lot of admin, duties. And so I talk about how you can connect your cluster to an OIDC server. Okay, OpenID Connect. OpenID Connect is a kind of authentication layer written on top of OAuth 2. And some of you may be familiar with OAuth 2 because most web applications, they make use of it for security purposes to make sure that they're able to get the valid token that they need to use to talk to whatever they need to talk to within the cluster. And so I'm going to review briefly what I talked about the last time, because today I'm going to continue from there. All right, so what we did last time was I set up an OIDC server where basically I use the OIDC server provided by Google. Okay, Google has an OIDC managed service. So in order not to deploy your own OIDC server, you can use a managed service. If you wanted to deploy yours, there's something called Cloak. There's Cloak, there's DEX, and a couple of other options that you can deploy in-house. But these days I prefer to use managed services. Makes your life pretty easy and also reliable. So what we did was we set up an OIDC server on Google Cloud. Then I configured my cluster to talk to the Google OIDC server. And the way it works is that I have to create users. Basically anybody that has a Gmail account. Anybody that has a Gmail account can potentially use my cloud or use my cluster because I don't have to manually create them, okay? So once you have a Gmail account, it means you can get authenticated into my cluster, all right? So that is the whole objective of that. And I'll show you, take you through those steps briefly, and then I can start today's presentation from there. Okay, so assuming that you want to set up your cluster to connect to OIDC, first step is go to your cloud environment or go to Google in this case, which is the one I use. So let me bring the page for you to see here. So this is my Google account, Google Cloud account, and in there I created this OAuth 2 client here. I call it the Kubernetes cluster. So I created those credentials, and then I had to configure my cluster to use the credentials. To do that, I had to go here, sudo su minus. So I'm using kubeadm to deploy this cluster. So I went to there, and then I open up, I go to manifest file. Depending on the cloud, on how you deploy your environment, this step will differ. So I went to Kube API server, and then I put the configurations. So if you see here, I have OIDC issuer URL, it is pointing to Google. Then I have the OIDC username, is pointing to email. So we'll be using email to connect. Then I have here an OIDC client ID, which is that long ID that I have there. And that ID is coming from here. See this starting with 36. So let me click on that. So when I click on that, you will see the ID that I use to configure my cluster. So let me move it aside here, and the ID, we see it over here. All right, so you can see that ID there starting with 3678. That's what I have here, 3678 on and on. So I've done this already, so I don't have to do it now from the last time. So essentially, I'm not saving it. It means that this cluster is connected to the Google OIDC server. What that means is that any person that has a Gmail account, I can connect that user to my account, to my cluster. Okay, but there are two steps to it. First is the authentication. The second is the authorization. So last time I talked about authentication. Today we're talking about authorization. But to make that a complete experience, I'm going to add a user. I'm going to add a user, and so you can see the entire process of how you can add a user that has a Gmail account to your cluster. As a matter of fact, if this cluster were publicly available, if I had deployed it on AWS or something like that, I could ask you guys to follow along. I could send you the credentials you need that will enable you to connect to my cluster, but it's not publicly available, so I'm going to demo that for you. Okay, so now that the cluster has been set up and connected to Gmail, Google OIDC server, I need to learn to add users. To learn to add users, you need to install in your laptop a tool called Kubernetes OIDC helper. You need to install this on your laptop. There's a client for Windows, there's a client for Mac, and there's a client for Linux. So this one, I'm using a Mac machine, so that is the one I'm going to use. Take note of one thing. This is my cluster running on a different server within my network, but here is my laptop, okay? So I have this OIDC server here, server client here to run, and when I run it, I need to pass the client ID, the one that you saw me show you earlier on Google Cloud. I need to put the ID there. And also there's a client ID, which is this one here. If I come back here, this is the client ID. So pretty much I need all these credentials from my Google Cloud to be able to do these configurations. So assuming that you wanted to follow along, I will send you this. I can send you that line. Then once you install the OIDC helper, you can run it and then follow the steps from there. So you can watch me do that. What I'm going to do is I'm going to add a user that has a Gmail account. I already added myself. I have a Gmail account. I already added myself, and I'll be using that for demo. But I'll be using another account. It's actually the Gmail address for my daughter. So I'll use her account to add her here so you see how it's done. So I'm going to source this file. Okay, I'm going to source this file. That is, I'm going to run it. When I did that, notice what is happening. It came here it's trying to log me on to Gmail. This pops up. It's trying to log me on to Gmail. So now I have this Gmail account set up here. I want to use this one to be the one to log in. So I'm going to click on that. So once I click on that, it's going to give me a code. It gave me a code. I need to copy this code. Then I need to come here to my shell, and I need to paste it. When I paste it, see what happens? It gave me all this line here. It said, add the following to your kube config. Now, for those of you who are new to Kubernetes, before you can use it, you need to create a profile for a user. Okay, you need to have three things. You need to put details about the cluster you are connecting to. Then you need to put a user, and then you need to put a context. All right, three things need to be available. So again, remember, this is not the cluster. This is my laptop, but I'm going to be able to connect from my laptop to that Kubernetes cluster that is running here. All right, so I'm going to copy these lines here. Okay. And I'm going to add it to my context file, just like it says there. So I'm going to copy. I don't have to. I don't need all those. I'm going to copy all this. Let me copy from here. All this line, everything from here. I'm going to copy that. Okay, and the file is this. I'm going to go to my home directory of cube, and then the file is called config. So in this file, I already had my cluster configured. This is the cluster that I'm connecting to. Let me show you the cluster I'm connecting to. This file is very large, but that is because I have a lot of clusters. If you are doing this, you won't see a lot of information. This is the cluster I'm connecting to, 192.168.0.21. You can see the IP right there, 192.168.0.21. So I already put the information about the cluster that I'm connecting to. So that is already there, which is good. And I actually already have a user for this email, but it's pointing to my local cluster. This one here is pointing to my local cluster inside my laptop. So I need to change the configurations to point it to the cluster of this one here, the one ending in 0.21. So this is the context. In the context, I'm going to change the credentials, which I already have them here. My cluster is, I call it in-house. So I need to change this one now to in-house cluster. Okay, that's the name of my cluster, in-house. Then the namespace is going to be the default namespace. The username is the same. I'm not going to change that, and the context is the same, which is this one here. Okay, so I'm going to go to the end of the file. Going to the end of the file, and all this information here, which I had for my daughter before, I'm going to replace it with the new one, the one I copied. So I'm going to paste it there. Okay. So now hopefully everything should be fine. Let's see. So that's all I need to do now. So now there's a command I can use, kubectl config get context. Kubernetes config get context. Okay, it says overloading, error loading file. Okay, so let's see, it's giving some errors. So let's open up that file again and see. So let's go towards the end. I have name is there, should be good. None of these other ones should matter. Let's go to context. Okay, so in the context here, I have in-house cluster. Let me ensure that the name is correct. In-house. Okay, so let's see if that is there. Yeah, that's the cluster, the in-house cluster. Okay, let's search again. All right, so in-house cluster default. Okay, default. Okay, that is for my, that was for me. Now I'm doing it for this one here. In-house cluster default, and the email is there, and the name is there, and the contact is there. Current contacts. Okay, so I think this should work. Let's check again, see what's happening. Okay, so Groupctl config get contacts by 134. Okay, if this doesn't work, I have this one namespace in-house cluster. Okay, I think it's this one. There need to be a space there, I think. So let's do it again. All right, so that is fine now. So now I have all these contexts. So see the context to be like profiles. These are profiles of different clusters that I can connect to from my laptop. Remember, kubectl is just a single command, but I can I can connect to so many clusters from my own laptop if I'm the administrator for those clusters. So now this is the default. This is the current context that I am. How do you know the current context? We have a star in front of it. Okay. Now the one I want to go to now is this one, Uloma, which I just created. So I'm going to say Groupctl use context. I'm going to say use context, Uloma, and say config. You need to be Groupctl config. Use context that you say they are switched to that. So if I say Groupctl get context, like I did earlier, now Olama is now the star. So this is the default cluster. Okay, very good. So I can say Groupctl get nodes. When I say get nodes, it said error from server, forbidden. Node is forbidden. User this at Gmail cannot list nodes. So this is where I'm starting today's presentation. I managed to add a user that has a Gmail account to my cluster. However, there's still another step I need to perform, which is giving the person authorization as to what he or she can do. And this is where RBAC comes in, role-based access control. So now that the user is not able to do anything, let's first of all go to my cluster and define some roles, define some policies for this user. So I'm going to go here and I'm going to open up these two files, okay? Cluster role .yaml. So this is where today's discussion is going to be centered around. All right, so I have this role here. That role is already created. If I say Groupctl get roles, I have the role that I just showed you, which is get cluster roles. Okay, so let's grab admin. Okay, so admin role is there. Remember, if I cut this file, the one I just showed you earlier, cluster role.yaml, the name of this role is admin role. So admin role already exists because I already created it. If it were not created, I would do kubectl kubectl create -f, and I do cluster role.yaml. If I do it again, it's going to complain that the role already exists. Okay, so role already exists. So I already created that. The second step is I need to apply this role to the user that I just created, which is basically user Olama. So I'm going to open up another file that will give me that. So the name of the file here is cluster role. The role. Okay, so this will be cluster role binding. Okay, cluster role binding.yaml. So here we're going to look at this file in a moment, but for now, let me just change the email address, which is basically olama@gmail. That is the name of the user. So if I do that, olama@gmail, and I save it, then I'm going to delete that role and create it again, or I can do apply kubectl apply -f cluster role binding. So I'm going to apply the role, and it said that role has been applied. So let's go back to my laptop, and now if I issue this command, if I issue get pods, it cannot list resources in the API group in the default namespace. So this is meant to give the permission for the user. But let's check first. Let's check to ensure that this is actually fine. If I want just to be sure, I will delete the previous one. So once I get it working, then I can explain how RBAC works. And then that is pretty much what I have for today. So let's do kubectl delete -f and do the cluster role binding. Okay, I deleted it. So let me look at the file again. Cluster role binding. So here the user is that cluster role binding, that's the name. Okay. All right, so the username is correct. Let me make sure that the username is correct. Sorry, this is Olama Igbe, not just Olama, so probably my bad. So let me create this role again. Let me create a role again. I'm going to create it again. All right. So now I need to go to the file that I just, which is cluster role binding. So I'm going to change this email to lamaigbe@gmail.com. So let me save that. Okay, let me apply the role again because I made a change. All right, so hopefully this should work now. So now if I go here and I run the command that I ran earlier, see now it's working because I already gave the permission to her to do this. So if I do pods, all that is working now. This is perfect. So this is pretty much where I'm going to kick off the presentation from today. So hopefully you've seen what happened. The fact that once you add a user to your cluster, it doesn't mean that that user can use anything, because by default, that person has just no authorization to do anything. Now you can grant authorization to the user by creating RBAC policies. Okay, so let's look, now that we see how it works, let's look at RBAC and how you can use it. Okay, so RBAC, role-based access control. This is not something just particular to Kubernetes. Almost every IT infrastructure has these capabilities where you can add users, which is authentication, then authorize them to do whatever they need to do. That is to give them the authorization to do whatever they need to do. So it's basically a way to control access to resources. These resources could be the compute resources within your environment. It could be the network resources within your environment. Okay, so that is basically role-based access control. It's similar to what we do in AWS. If you're familiar with AWS, in AWS you have to create policies. Policies are usually created in JSON. Then you need to apply these policies to users, IAM users. Then once you do that, these IAM users can begin to do things on the AWS environment. So first step, create the IAM user. Second, create policies and apply those policies to the IAM users. It's the same process here. First stage here is create a user. I did not have to create a user manually because I connected it to an OIDC server, which has been provided by Google. Then the second is I need to create a policy. In this case, I'm going to use the Kubernetes way of creating policies. Like I said, on AWS, you create them with JSON, okay? Then the third is to apply the policy to the user. And you saw me, I did all those steps. I created a policy which was there before. Then I applied that policy to the user that I added to my cluster. So it's the same thing that we're going through here. So it's not peculiar to Kubernetes. That is what you do in IT. So if you see what I've been doing here, if you're not familiar with Kubernetes before now, before you can create an object in Kubernetes, you need to create a file that describes the attributes of the object you want to create. So you're going to use a lot of YAML files. Here, you already saw the YAML file that I created here. One of them is here, cluster. This is the one I just created for the cluster role binding. And if you pay a particular attention here to this line, it says the API version is rbac.authorization.kubernetes.io/version1. So basically, this is the API version that you need to use for creating your policies. And that is what I have here on this line. You need to use that. Okay, you need to remember to use that because in Kubernetes, every object you create needs to belong to an API object. You need to have an API object group that it belongs to. All right. Then once you do that, another thing important to use with RBAC is that you need to make sure that your API server actually recognizes RBAC. Okay, so let me show you here. In my cluster here, I need to ensure that, let me log in, sorry, it's gonna be here. So the cluster I have here, I need to be enabled for RBAC. So to do that, I'm going to go to where I went to earlier. Let's see, Kubernetes, manifest, Kube API server. So if I go there and I search for RBAC, you see there's RBAC here. You need to enable it. Otherwise, your cluster will not recognize RBAC. The reason for that, well, partly is because RBAC was a new feature. It wasn't there from first day of Kubernetes. It was something that came on along the line. I think since Kubernetes 1.6, it's been stable, and it's a feature that a lot of people were waiting for. Okay, before the RBAC, they had something called the ABAC, attribute-based access control, which was difficult to configure, and it wasn't doing most of the things people wanted it to do. So RBAC, even though it's fairly new, you need to enable it on your cluster before your cluster will recognize to use it. Okay, so just make sure that you enable it on your API server. If you're running it from the CLI, you can run something like that, but it depends on the cluster or how you deploy your cluster. Okay, so if all this is in place, make sure that your API server is configured for RBAC, then you should be good to go. Now, this is where you need to pay attention. For you to create RBAC policies, you need these objects. You need a role, a cluster role, a role binding, and a cluster role binding. You already saw me use this one. I already used this one and this one. Cluster role and cluster role binding. So what are these objects? Kubernetes has a lot of API objects. You can see here, if I say Kubernetes API resources, Kubernetes API resources, I enter, I'm going to see a lot of objects. Here, it showed me the name of the objects. There's a short name for the objects, and there's the API version for the object. Then it tells me whether these objects are scoped to a namespace or whether they are not. And then it tells me the kind, okay? The kind of the object that we're dealing with, okay? We'll see some of those when we start creating those YAML files, okay? So I can also say -o wide. If I say -o wide, it will show me more information. And this is going to be useful for when we're creating policies. Take note of this. I'll come back to this. You have different API objects like create, delete, delete collection, on and on. These are called the verbs, the API verbs. These are pretty much similar to what you have with CRUD. You know, API CRUD, like RESTful CRUD, CRUD. CRUD means create, read, update, and delete. That is the acronym, CRUD, create, read, update, and delete. So these are the verbs. These are the things you can do on each one of these API objects that we have here. Okay, so Kubernetes has a bunch of these API objects. The one we're dealing with, the one I wanted to show you, or at least the ones that are important for role-based access control, let's look at them. Groupctl API resources, let's grab role. That one is important. Okay, so this is roles. This is role bindings. This is cluster roles. This is cluster role binding. Okay, 4 of them. Those are the ones I have here on the slide. Role, cluster role, role binding, cluster role binding. You can look at the names here as well. Cluster role binding, cluster role, role binding, and role. So those are the 4 main objects that you need to work with Kubernetes role-based access control. And I'll tell you the differences between them in a moment as we go through the presentation. Okay, so now that we understand the objects you need to use, let's discuss role and cluster role. So basically, these 4, you can see that there's role and then there's cluster role. 2 of them are similar, role, cluster role. Then we have role binding, and then we have cluster role binding. So basically, let's understand that first. In Kubernetes, we have something called namespaces. Kubernetes get namespace. It shows that I have all these namespaces here. The concept of namespace in Kubernetes is a way for you to isolate your workload. I can create a namespace and call it testing. I can create a workload and call it pre-prod. And then I can also call it production, or I can name it by teams. Okay, so the aim here is that I can isolate my workload. Certain resources have to be in the workload. They have to be in the namespace. You cannot use them outside of the namespace where they belong. A quick example is this. If I say Kubernetes get pods, I'm seeing that 3 pods are running. Now, these 3 pods are within my default namespace, okay? Because if I don't specify a namespace, it goes to my default, which is this one here. So even if I put it and say Kubernetes get pods minus namespace default, it's still showing me the same thing. So if I'm trying to access my default namespace, I don't have to mention anything. On the other hand, I can still go to another namespace called this one here, kube system. If I go to kube system, I will see a lot more resources. So you can see the isolation I'm talking about. This command, the same command here, except on a different namespace, gives me a different set of objects. And then when I did it on the default namespace, it also gave me a different set of objects. So I can easily create my namespace. I can say Groupctl create namespace meetup. So that's a namespace there. I can say Groupctl create namespace, and now I have a meetup namespace there. Then I can say Groupctl create deployment. Let's say Nginx. I can say minus image equals Nginx. I can say minus namespace is the namespace is meetup. So let me put the things there. Okay, sorry, minus n. So now I created my resources in the namespace Nginx. So now if I say Groupctl get ports minus n meetup, I'll have my object is still being created. So you see how I put it inside that particular namespace. So it's now running. This is how you do things in Kubernetes. Everything is kind of divided into different rooms, if you like, different namespaces for organization and also for a little bit of security purposes. So again, going back to the command I ran earlier, when I say Groupctl API resources, and I say -o wide, see that some of them is going to tell me they are scoped to a namespace. Yes, namespace true, false. If it's scoped to a namespace, then it belongs to a namespace. Otherwise, it is a cluster-wide resource. So something is either applicable within a single namespace or it's applicable across the entire cluster. So if you understand that, you understand the differences between role and cluster role. If I create a role, that role is applicable only within a namespace. If I create a cluster role, then it's applicable across the entire cluster, across all the namespaces. So that is the reason why they have the different objects, roles and cluster roles. Roles, when you create them within a namespace, and then when you create them, this one here. So if I want, I can put in front here, namespaced. This one is also namespaced. Those two, they go together. This one here is cluster wide. It's not scoped to a namespace. That is, if you create a cluster role, it applies to the entire cluster, not to a particular namespace. So that's the difference between them. But those are the 4 objects that you need for creating your RBAC policies. Now I've talked about role and then role then cluster role. How about role binding and cluster role binding? These are the equivalent. These are the equivalent. You have role and role binding, and then you have cluster role and cluster role binding. So what is this one doing? The name binding. Okay, so that's what I was saying earlier. If you remember, I said first create a user, then create a policy, then apply the policy to the user. It's the same concept here. Role binding binds the user to the policy. Okay, so you need the role binding to assign the policy or the role to a particular user. Like you saw me did when I started. I have to come here to this cluster role binding. And then in there, I applied this role here, which was created earlier, called admin role. I applied it to this user here called ulamaigbe@gmail.com. So before then, the user was independent. It was isolated. Then the role, the cluster role, the admin role was also isolated. But role binding binds them together, connects them together. After that, they can work. Okay? After that, the policy applies. So that was what I did before I was able to run the command that Ulama was able to run from here, Groupctl get ports. Okay, so if I went back here and I just delete that role again, I'm just going to delete the cluster role binding, Groupctl, delete -F, cluster role binding. And I go here, this command is no longer going to work because there's no more role. This user has no role. Okay, and if I go back and create it, then the user can now use a cluster. Okay, so now I come here and the user now can run the commands. So you get the logic. You have the object, which is the user. We call it, actually Kubernetes call the user the subject. So you have the subject, then you have the role, then you have the role binding. The role binding binds the role to the subject. Okay, so I hope that is clear. Now, the only difference between the role binding and the cluster role binding is that the cluster role binding applies a role that applies across the entire cluster, while the role binding applies a role that only is scoped to a particular namespace and not the entire cluster. Okay, so those are the 4 objects that you need to be able to work with role-based access control in Kubernetes. So now that we have this overall idea, let's look at what we can do with them. Okay, and all that is explained here. When you define your role, it contains rules that represent a set of permissions. So we're going to look at a role and try to understand how to create one. Permissions are additive. So as you add more, the system will continue to add to what is there before. But you do not have deny rules. You cannot particularly deny an object. Though by default, everything is denied because, as you can see, if I did not apply the policy to the user, then I wasn't able to do anything. Okay, so that is what we have there. And then this is how a role is defined. And for this one here, it's probably easier. I come here and show you the roles that we have here. Okay, so I'm here and I'm going to go into the examples, and then I'm going to open up the file for a role. So let me open up pod reader role or YAML. Okay, so again, if you are not familiar with Kubernetes, if you've never worked with Kubernetes a lot before, this is how you do things in Kubernetes. You have to create an object, a YAML file that you describe the object you want to apply. Then after that, you can use kubectl to apply the file. So the syntax here is very similar. This is how you define your policies. The first thing is the API version you're dealing with. That API version for a role is always going to be this. That is the reason I show you here earlier in the slide. That you need to use it all the time. That is what that is the API group or the version that this belongs to. It doesn't change for a role. Then the kind is a role. The kind here is the Kubernetes object that you're dealing with. This can change. When this change, often this will change as well. These two, because the role, what you put here has to match what is here. Okay, so often 2 of them will change to match each other. And I'll show you an example as we move on. Then you have the metadata. You have the namespace. This is applied to a default namespace. Why? Because we are dealing with a role. Remember, roles goes to namespaces. So you need to specify the namespace that you want to apply this. If it were a cluster role, then you don't need to specify the namespace because it applies to all namespaces, basically. So we give it the namespace, and then we give it a name. In this case, the name of this role is called pod reader. Okay, a pod is an object. It's a Kubernetes object. Now you specify your rules. This is where you specify what the user can do. So basically, we have 3 sections here. We have the API groups, we have the resources, and we have the verbs. Okay, basically, this API group, you have to note the API groups you are dealing with. Okay, based on this object. Okay, so let me go back again to show you how you can get this information. Now, I already have it here, but if I say Groupctl API resources, and I say -o wide, So this command here is very helpful because in here, it shows me all the API objects I'm dealing with. Let me log on. Let me create another shell to my server so that I don't have to, so I can use two of them. So I'm trying to log on to the cluster 192.168.0.21. So that is the master node of my cluster. So now I can say, so here I already have this information. Yeah, let me open up the file here. So OIDC. So let me go to examples, and then let me open the pod reader YAML file. So in here, the version, you're going to see it here. Remember, we're talking about the role. Okay, so let's filter out the role. Let's do this command and let's go and grab role. So we're dealing with the role here. So in the role, this is the version that you saw here. That is what we see here. RBAC, authorization, Kubernetes IO. Then the namespace is there. The API groups. API groups, that is the group that this deployment belongs to. For that, we need to check the object for deployment. So let's go here and let's grab for deployment. I'm going to grab for deployment. Again, if you're not familiar with Kubernetes, it could be difficult to follow everything I'm doing, but you can go back and listen to some of the previous videos. So here, this is the deployment object, which is what we have here, deployment object. So the group is apps. Okay, so here we can see that it's apps v1. So that is why we put the apps there. And these are the verbs. These are the verbs that you can do on this object. You can do a create, a delete collection, a get, a list, and a patch. These are the object things you can do on this particular object. So we're only allowing the user to do two of them, which is list and watch. The user can only do list and watch. So we are going to see how I'm going to change some of these policies and how they're going to affect the user that I just configured. So basically, this is how a policy file looks like, a role file looks like. Pretty much everything here is always going to be standard, as what you're going to configure a lot of time are going to be in the rules. And I'm going to show you a few examples once you understand what I'm talking about. Okay, so now we have this file. Let's look at the role binding. Let's look at the role binding to see how that works. Sorry. So let's do vim. Let's do the role binding pod reader. Role binding pod reader. So this is another file. This is for the role binding. Now, this one is still the same. The version and everything here is still the same. That doesn't change. Now we have that. Then we have the metadata information. We give it a name. We tell it the namespace. Then this is where we're going to apply the subject. This is where we need to put the user. Here, the kind is a user. And the email or the name of the user is here. This applies to me. But I can change this one to, since I'm using the new user, I can change this one to represent my daughter's email, Gmail account, which is that. Okay, this doesn't will not change. It's still what we have here. Then the role. This is the role that we just created. Remember the one we just finished with? The name of that role was pod reader. So we now have the role binding. You need to have two sections: the subject, which is the user, and the role reference, which is the role you just created. Okay, so let me save this. So you can see that with those two files, I can now apply a new policy to this user, okay, to the user that I just created. So that is role, and that is role binding. And actually, the one we did earlier was cluster role and cluster role binding. So we've seen all the examples. So I can do cluster role.yaml. And now you see the only difference is that the name is now cluster role instead of role. And then we have all these policies here also that we talked about before, the API groups. So they are very similar, that's what I'm saying. The only difference is the name of the objects and then a few other things that we change. Then if you do the cluster role binding, here you also see there's a subject and then there's a role reference. But this name here is no longer role, it's now cluster role binding. So pretty much we've seen the 4 examples of how you can apply a role to be within a specific namespace and the entire cluster environment. So at the moment, this user I configured here can do things like Groupctl, gate nodes. Okay, it's able to do this because node is a cluster-wide resource. It's not a scope resource. So let's change this. Let's change this policy and give a localized policy. All right, so given a localized policy, I'm going to delete this row that I already gave her. I'm going to say Kubernetes delete -f, and I'm going to delete this one. Actually, I don't have to delete that, but I need to delete the binding. So I need to delete the binding. So let me go to the folder. The folder is here. So I can say Kubernetes delete -f cluster role binding. All right. So again, the user should no longer be able to do nothing because the role is gone. So now let's apply a local policy. This will no longer be a cluster-wide policy. Let's just apply a policy that applies to just this namespace. So one of that is this one here. I believe this is already created, but let me see, Groupctl create -f. If I do that again, if it's there, it will tell me I need to give error. Okay, that is already there. But for the role binding, the role binding, let me look at the file again, so to make sure that it's going to do what I want. But no role binding. Okay, so now we have this is going to be in the default namespace. And okay, so that should be good. So let me do Groupctl delete -f role binding. Okay, it's deleted. Remember, I just made some changes. That is why I'm deleting it. I changed the name of the email from mine to my daughter's. So now I'm going to create it again. Now that I create it again, this policy is now active. So let's try to do what we did earlier. The user will still not be able to do a cluster-wide resource anymore because node that we're trying to get here is a cluster-wide resource. It's not a namespace resource. So let's try pods. Kubernetes get pods. That is also not working yet. So we need to go back and see why it's not working. Okay. So Kubernetes get pods, Kubernetes get deployments. Okay, none of this is working. So now let's see the reason why that may not be working. So we're dealing with local policies now. So let's look at both of them. Kubernetes role, Kubernetes pod reader. Okay, so this is the one we're dealing with. Actually, this applies to deployment objects. We apply this one to deployment. Okay, so in the deployment, we gave list and watch. So you can see that I don't even have get here. So let's make our life easy. Let's add a get here. Let's add a get to this list. Okay, so since I add a get, let me save it. And I can do Kubernetes apply. When you make a change to your YAML file, you can always apply the changes. So I'm going to say pod reader. Okay, so that change has been implemented. So let's do again Kubernetes get pods. No, okay, so pods are now working because I made that change. Now also if I do deployments, deployments should now work, okay? Because I now have them in this file here, Groupctl Vim pod reader. Okay? So that has been created here, and that has been applied in the row binding pod reader that has been applied here to this user. And because of that, I can now do what I'm getting. So already I believe you're having a feel for what I'm doing here. These policies are helping me to control what this user can do or not do. And in fact, I can stop this user from doing anything. And then of these objects I have here, Kubernetes API resources, these are all the objects that a user can work on. But I'm restricting the user to just work on this, and then another one called deployment. I'm restricting the user to just work on this too. Any other objects, the user is not going to be able to do it. So let's take example. Groupctl get. Okay, actually, that was on the cluster. Actually, that was a different thing. So, but this one should work. Deployments. Groupctl get deploy. Groupctl get deploy. Okay. So actually, this user is not allowed to do this here. I was running this from the cluster here, so we still have to figure out why this is not working. Okay. So let's figure that out. We already deleted the resources here. So you can see managing all this can be a little bit daunting. And that is why later on in the next meetup, we're going to see how we can apply these policies from a centralized position. And so we'll talk about that when we talk about things like Istio, how Istio is going to help us manage all these policies. Okay. So far, this user is not able to manage anything yet. So let's look into that and ensure that our user can actually manage this cluster. Okay, so we're on the cluster here, and let's go back and look at this file, Vim pod reader. In the pod reader here, we have extensions and apps, and then we have deployments. Let me add also pods here. Let's add pod. This is where you specify your resources. If you want a lot of resources, you need to put all of them here. Okay, so pod. And a pod is within what we call the core API groups. So a pod is within the core API group. That is how you represent a core API group. This one here, deployment, belongs to extensions. So that is why we're putting it there. And these are the objects we can work on: the get, the list, and the watch. Okay, so now we have this. Let's run this. Let's apply. Groupctl apply -f pod reader. Okay, then let's look at the Groupctl delete -f row binding. Let's delete that first, and let's create it again. Let's apply that policy to this user. And let me cross-check again to ensure that the email address and everything, I didn't make any mistake. So look at it here. I missed out the I. So no matter what I do, this is not going to work because the email is not correct. So I just have to put the I for the last name, which is IGPE. Okay. So sorry for my typo. So now I need to create this again. So if I create it again, it's saying already exists. Okay, let's delete it. Let's delete row binding. Or let's apply it. You can just apply instead of deleting and doing it all over again. Okay, so let's go back to our laptop. Hopefully this should work now. Yeah, that is working as expected now. So you see how the policy is making it work. Now, when I try to get ports, it said you cannot list ports. So I'm not allowed to do that. If I try to get secrets, there are a lot of Kubernetes objects. None of this is not going to allow me to do them. Get secrets, get config maps, get nodes, because none of this is not going to be able to do it. The only thing that this user can do is what we asked him, what we gave to him here in the pod reader. The pod reader here, we said API groups are this. And the reason it's not allowing me to do pods, I believe I need to put S here, pods instead of pod. So let's make a change to that and do that again. So let's do Groupctl apply -F pod reader. Okay, no, that was pod reader role. Okay, excuse me. So now that we have that, let's see if the user can now list pods. Get pods. Okay, that's better. The user cannot get pods, cannot get deployment. That is the only thing the user can do. Any other thing is not going to allow to do. Secrets, config maps, roles, nothing. Why? Because in this file, we said you can only access these objects, pods and deployment. And you can only do a get, a list, and a watch. These are the only things that this user can do because we scope him or her to this default namespace. Now let me show you this example too. Groupctl get pods. It's working. Now if I say Groupctl get pods -n meetup, remember the one we created earlier? Okay, so meetup is in the default namespace. That is why it's doing that. If I say Groupctl get, if we do that, group system. Oh, sorry, I keep mixing them up. This is my cluster. This is the user. This is where I should do the test. So Groupctl get pods. That's fine. Groupctl get pods -n cube system. Now this should not work. It's not going to be allowed because it's only scoped to this particular namespace. Okay, so I hope this is getting clearer. You know, I've been showing all these different examples now, so hopefully it's getting clearer. The whole point here is that you have the ability to restrict this user to do only the things you want this user to do. You can do it either by restricting the user to a particular namespace or giving him the capability to do it across every object in the entire Kubernetes cluster. And you do that by the type of policy you defined. And then after the policy, you use the role binding to apply that role to the user. So that's all I've been showing you here. And pretty much that is what I have, but I want to help you differentiate this because I get this question a lot. Anytime we do this in our classes as well, people are always confused. What is the difference between a list and a get? What is the difference between a list? What is list object and what is get object, and what is the difference between them? Because if you look at it carefully, they look like the same thing. When I do Groupctl, kubectl, get pods, get kubectl, get pods, it's actually getting listing my pods, right? It's listing them here, list pods. And so what's the difference? Well, the answer is that get is for specific objects, okay? List is for all the objects. And you'll see, I'm going to demo this for you in a moment, and then it will be clearer to you, okay? List can list all objects. For example, if I say Groupctl get pods, this is list in action. List is the one that is being invoked. Even though I use the word get, list has been invoked because then I'm able to list all this. But I can also say Groupctl get pod. I can give it the name of the pod. Okay. Now this is a get. If I give someone a get object, that person can do this. and the person will not be able to do this. But if I give person the list object, then the person can list all the objects, okay? So let me show you, maybe it will be clearer when I show you. So we're going to modify the policy that we have here. The policy we have here is pod reader. Okay, so we can see that in this policy here, we have pods and we have deployments. These are only the objects we can work with. Now I'm going to restrict now to a get, just a get. So I'm going to delete this capability here and leave it at, in fact, let me remove the watch as well. I'll come back to watch in a moment. Let me leave it as get. This user can only do a get, okay? So I'm going to save it, and then I'm going to do Groupctl apply -f pod reader road or YAML. So I'm apply the changes. Okay. So if I say Groupctl get pods, I need to come back here because the user there is not the same as the user here. Groupctl get pods. You see now it's not letting me work when I say get pods. Okay. But if I say Groupctl get deploy, none of this is allowed because I put a list. But because I know the name of the object, I'm going to cheat. I'm going to say Groupctl get pod. Can you see that that worked? Because get only works on a specific object. It doesn't do the listing. Listing is when you want to show all the objects. I can also do the deployment. I think we have deployment there. If I say Groupctl get deploy, the name of the deployment was Nginx deploy. The name of that was Nginx. So that also works. But if I remove Nginx, it's not going to work because that is a list. So now let me change, let me modify it again, and you see what will happen. So let's make the change again here. Now I'm going to put a get, no, sorry, a list. To apply it, it's configured. Excuse me. So now it's a listing. So if I say Groupctl get deploy Nginx, see this no longer work. This was the one that was working before, right? Because we've removed the get, but now this will work. See, it's listing all the objects. This is the one that was not working before. Now if I do get pod, this will also now work. But if I say get pod and I give it a specific, it will no longer be able to work. So if I want to make all this to work, and then I need to come back here and then change the policy. I'm going to add a get. So a get, okay, then I'm going to apply the policy. And now both specific and non-specific should work. So go back to the user, and then this should work. And if I remove that, this should work. Same thing with pod. If I say get pod, this will work. And if I say get pod and I give it a specific, this should also work. Okay, so I hope that is clear. The difference is that get can only work on a specific objects, and list will list all the available objects that you have. Another thing is, I want you to understand is the fact that some of these policies, some of these objects, they depend on others. Okay. So if before, for example, before I can use this one here, let's go back here. I'm going to open up the file, pod reader here, and I'm going to put a watch. Okay, so I'm going to put it here and show you what I want to show you. Then I'll start reducing. So I'm going to do a watch. Watch allows you to continuously view the objects you are dealing with. So I now added a watch. Before I apply the policy, let's see if this user can watch. Get Kubernetes get deploy -w watch. See, it said deployment watch not found. Or let me see. Okay, so let's just do this. There was a typo there. Okay, so it said error from server forbidden. So I'm not able to watch. It says forbidden because I don't have the policy. If I do for pod, it's going to do the same thing, forbidden. Now let's apply the policy. Then that error should disappear. So let's apply the policy here. Okay, so now watch should work. Redeploy -w. So watch is now working. So what is happening is going to continuously refresh. If I give it time, if there's any change, it's going to continuously refresh. Same thing if I do for the ports -watch, it's going to stay there and continuously refresh. So I can Ctrl+C to cancel that. Okay, so now we're going to show that for watch to work, we need to have list. Okay, because watch depends on list. Because if you're not able to list objects, how can you watch it? That is the whole idea. So let's go back here and just remove, we're going to remove the list. Even though we still have the watch, but this should not work anymore because we have removed the listing. So let's apply that. Then let's come back here and issue this command. See, now it's no longer able to watch. Okay, even though watch is there, but watch is not going to work because it's not able to list objects. So you can see that some of this depends on each other. You need to pay attention to configure your policies very well. And again, like I said, this is something that you do when you're really conversant with with Kubernetes. That is when you start working with policies. So let me go back. And then let's put back the list. And then it should now work. Let's put a comma in here. So let's apply the policy. And then let's come here. And now this should work with no problem anymore. Okay, so take note of that. Certain objects depend on other objects before they can work. Also, another thing I wanted to mention is this. See if you can watch this. I'm going to delete. I have some deployments created here. I'm going to say Kubernetes delete, delete, Kubernetes delete, deploy, Nginx. Okay, it's not going to Kubernetes. It's not going to let me delete. So what I need to do is I'm going to delete them here before I go back there. So I'm going to say, you know why I cannot delete, right? Why this user cannot delete? Can anybody put in the chat why this user is not able to delete? Anybody? Why? The reason is because it doesn't have the policy to delete. The policy doesn't allow this user to delete, so it won't be able to delete. So but I need to delete those. So let me help the user to delete them here. Kubernetes delete deploy Nginx. Okay, I'm going to delete the other one, Nginx one. Okay, when I do that, if I come back here, none of these objects should work anymore because we basically got them deleted. Okay, no resources found. Say pod, no resources found. Okay, so what I want to show you is this. When you create a deployment object will automatically create pods because deployment objects control pods. All right, so watch this. If I say Kubernetes get pods, I don't have any port created. If I say get deploy, I don't have any deployment created. Okay. Now, if I say Kubernetes create deploy Nginx, I give it the image equals Nginx. Oops. Minus image equals Nginx. Image. Okay, now that is created. Now I'm going to do a new one like I did before. I'm going to, well, let's see this one first. Kubernetes get deploy is there. If I say get pod, it's going to create pod automatically for me. Okay. Pods, deployment create pods. You don't have to do anything about it. It's just the way it's programmed to do. Now this user should be able to view them now, but this user will not be able to delete them because he has the permission to do that in the default namespace. Remember, this is the default namespace, and we gave this user the power to do anything in the default namespace. Any other namespace is not going to be able to do it. Okay, so the point I want to make and sure you understand here is that even though deployment object create pods, if I want the user to be able to view pods, I have to give the permission also for pods. So if I go back to the policy here, this is the policy that we'll be using. Let's have it up and running. Okay. Now I'm going to remove pods. Okay, so now it's going to apply only to deployments. And then we're going to apply the policy. Let's apply the policy. All right, so this user can now get deployed like before, but can the user list pods? No, it cannot list pod because I didn't allow the user to list pod, even though pods were created by deployment. So you need to pay attention to that as well. These two always go together. What that means is that since these two always go together, if you are creating a policy for them, you need to ensure that you allow both of them, because giving just one of them is not going to make them work. So let me go back, and then I'm going to put it back, and then we should be back to where we were before. Pods. Okay, I have that in there. Now apply the policy. And now the user should be able to list pods as well. Get deploy, get pods. Okay, very good. So hopefully all that makes sense. What I want to talk about next and conclude, we're going to conclude soon, is to tell you that the object, there are two types of users in Kubernetes. That is two types of subject. The first user is called a service account, The other one is called the actual users like you and I. Now, Kubernetes has an object for creating service accounts, but it doesn't have an object for creating real users like you and I. So what we just did here was we were able to connect to an OIDC to manage real users like you and I. But the service account, those ones that are used by the system or by our own applications, those ones are still going to be managed by Kubernetes. However, when it comes to applying the policies, we can still apply policies to service accounts as much as we do to real users like you and I. The only difference is that in the role binding, you just need to change the subject. Okay, so for example, if I say Groupctl get service account, this user cannot list service account because, but if I say get service account, I have a default service account here. If I say get service account minus n cube system, I have a lot of service accounts here. So why is this important? Well, let me show you this. Okay, let me say Groupctl edit. Okay, let me say Groupctl get pods first. Groupctl get pods. I have one pod here running. I'm going to say Groupctl edit. I'm going to change this file. Okay, Groupctl edit pod. I'm going to edit this pod. Okay, so -o YAML. All right. What I'm simply doing here is I'm opening up this file, the YAML file for this file, which is long. Then I'm going to check for a place called a service account. Can you see there's a service account there? In other words, anytime you create a pod is a container, right? A pod is where your microservices get deployed onto. It is a deployment unit in Kubernetes. So when I say, when I create a pod, automatically a service account gets injected into this pod. However, this default service account may not have the right permission or the right policy that I want it to have for this particular microservice that I'm creating. If that is the case, I want to proactively create my own service account, then inject it into this pod rather than Kubernetes injecting the default one for me. Because the way it works is, if Kubernetes discovers that you haven't given it any default service account, it will inject one on your behalf. And like I said, that may not be what I want, because either this one have too many capabilities or it doesn't even have enough capability for me to use it. So you can create your own service account, and it's very easy to create. Just a Groupctl create service account. I'm just going to call it my name. Okay, so I can say Groupctl get service account, and I have my name there. So then I can create a role, and then a role binding, or a cluster role and a cluster role binding, and apply the way we did to real users. So in this file here, pod reader role, if I go to role, so in there, instead of putting my name here or the name of the user, I can just replace it with a service account name. And once I do that, I can apply the policy. Okay, I can apply the policy, and then when I create my pod or deployment object, I can ask Kubernetes to use this service account called Damien, because that is the one I want it to use. Okay, so I have all these type of different ways of doing things, applying the policy to the real user or to a service account user. Both are allowed, and you can do that to control your applications. Okay, so pretty much I think that is all I wanted to show. So in the presentation today, for those of you that are absolutely new, I went through, took you through a brief overview of Kubernetes and the problem it solves. Then I show you the architecture and what it looks like, how to see your cluster, Groupctl, get nodes. That will give you information about the cluster you're working with. And you notice that everything I do on the master node. I don't worry about the worker nodes. I do everything on the master node. I can do it directly on the master node, as you see me do here, or I can allow users to connect my cluster from their laptops. In that case, individual users need to create their own profiles, like you saw me did here. I need to create my own context. And once you have that, then you can connect remotely to the cluster, irrespective of wherever that cluster is. So long as your laptop is reachable to that cluster, you can manage your Kubernetes cluster from anywhere. Okay, so I took you through that introduction to Kubernetes, and then I talk about how to connect your users through an OIDC provider. And this is what you do in production environment, because there are a couple of ways you can add users to Kubernetes. You can do them manually by allowing them to use certificates or even creating username and passwords, but these are not for production environment. These are not scalable solutions. So when you move into production environment, you just naturally want to have a solution that is less management overhead. And OIDC is a standard which people are happy with. So I connected my cluster here to the Google OIDC's provider. And so I can add any user that has a Gmail account to my cluster. And then I showed you an example of adding this email address of my daughter to my cluster. And then after that, we started to look at how you can allow, give some permissions or some authorization for this user to use my cluster. And so we play with different types of roles. We play with role and cluster roles, and then we apply role binding and cluster role binding to this user. And then we play with the different scenarios. And then after that, I show you the differences between a get and a list, which is often very difficult for people to understand. So in the process, I also showed you that you can apply these policies not just to real users like you and I. You can apply them actually to service accounts as well. And also I showed you all the Kubernetes objects that are available. If you just run Groupctl API resources, you see all the Kubernetes objects. If you do -o wide, that gives you even more view. And here you see all the things you can do with your policies. And this gives you the groups you can apply to your policies. I see the API groups are here. In the API group, all the API groups are here. So that when you're creating your policies, you need to specify the groups. Because like in this one here, this one here, if you look at Groupctl cluster role, let's look at the role, the one we had earlier, which is board reader. See the API group is there. You need to specify the API groups. I need to specify the resources. I need to specify the verbs. So basically that command is very important for you to figure things out. Because if this don't match, if for example, I put a pod here, but I get I didn't put this one, pod belongs to the core API group. If I don't put the core API group, this command will not work. At the same time, if I put deployment object here, and I don't put the right API group that deployments belong to, it will still not work. So doing this requires a lot of careful, coordination, because you need to understand what you're doing. All right, so that is pretty much what I wanted to show you guys today, exploring role-based access control in Kubernetes. And next meeting, if someone wants to present, then the topic might differ. If I'm still presenting, then I'm still going to proceed in this line. Maybe talk about Istio or some other aspect of Kubernetes security. So that will be coming up next. All right, so pretty much if anybody want to make a presentation in this meetups, please feel free to always let me know. This is a community group. We're just sharing ideas. If you are working on some interesting projects you want to share with your colleagues, please do let me know. Okay, so let me look at the chat. I see some interesting conversations, maybe some questions. I will look at those briefly and see if it's something we can answer. And then after that, we're pretty much going to close for tonight. Okay, space before in-house cluster. Thank you. So I was getting a lot of help, except that I wasn't looking at them. Okay, a space before. Thank you, Rack. It looks like you are quite comfortable working with this stuff. Okay, how to default to meetup namespace going forward? Okay, so that's a good question. There are actually there are some tools you need to install. There's a tool, I think I have them on my laptop, if I remember. There are some commands, Kubernetes, kube namespace. So you might have to Google that, but these tools are there that you can use them to switch permanently to a particular namespace. So if you say Kubernetes, like I said, you need to install it, and then you specify the namespace you're working on, then that could become your default namespace going on. But these are additional tools you need to install, okay? And if you Google, you'll find them. Otherwise, I will send the link because I did this some time back. Okay, that will be a current context. Yeah, that'll be that'll be the current context, but this is how I do it. I just use the tool to switch over. Have no idea. I'm a newbie. Yep, current context. Yep. Okay, someone is helping someone here. If you have a bunch of contacts defined and you want to jump around between them, you have to add minus context because that switch command. Yeah, that's correct. You need to each time you need to switch to a different context, or yes, you can tell the command in the context that you are working on. Also, another thing related to this is that you don't even have to leave your namespace. Okay, so for example, here, watch this. If I say kubectl kubectl get ports, okay, kubectl get ports is helping me to list all the ports, but I can also say kubectl get ports as a new user. The new user here was the one it configured was might be a Gmail. Now this command is now running as this new user. This one, it doesn't show it well, but now if I do list secrets, Sulamigbe, see, it's not allowing me to use because Sulamigbe doesn't have the permission to do that. But if I remove that, the user here can list secrets, but not as this user. So sometimes you don't have to switch your current context. If you know the name of the user you're trying to work as, you can always switch to them from the CLI. Great to know, good, thanks, no permissions. Okay, so I think most of the questions that were asked here were more like addition and also people helping themselves. All right, so very good. If you want to present, again, I repeat, please feel free. This is a community event. Feel free to come, tell me anytime you want to share your knowledge with your colleagues. But if no one wants to present, if I'm available, I'm always here to talk because this is what I do and I'm happy talking about this stuff. All right, guys, that's what I have today. Thanks so much for your time. Hopefully very soon, we're going to be able to meet in person for those that want to meet in person. But for those that want to continue to meet remotely, we're still going to have that capability. So we're going to have a hybrid, people coming in to meet and network with each other, and also people being able to join remotely to the meetup. All right, again, I hope to see you again in a couple of weeks. Stay safe and see you soon. Thanks for all the guys sending messages. Thank you.